welcome back to another video. I'll be talking about the Michaelis Menten kinetics. Basically, it just describes the rate of the enzyme reaction when it's catalyzed with the substrate. This is the main equation. And so the two S's here are basically the substrate concentration. Vmax is basically the max velocity of the reaction. VO is basically just the initial velocity of the reaction. And Km is just another word of saying the Michaelis constant. And typically at Km, we reach a velocity that's 1/2 of the maximum. And so basically this is just another way of how we measure the substrate's affinity. So let's say we have a very high Km. Basically that just means that the substrate is less affinitive to the reaction, because that just means we need more of that substrate to even reach 1/2 of the velocity of the maximum. But if we have like a less substrate concentration at Km, that just means it's more affinitive, because at a smaller amount it's able to reach 1/2 Vmax effectively. And so we could basically graph this in its form typically as shown right here. The y-axis is the rate of reaction, and x is the substrate concentration. And typically in a Michaelis-Menten equation, when you're graphing it, you tend to see a graph that's shaped like this. So at the point where we have a plateau, this is where we have our Vmax. And because we have our Vmax, we know that when we have 1/2 of the Vmax is where we have our substrate affinity. So let's say this is the halfway point of our Vmax. At this point here, we've identified our Km. There's another way you could graph this, which is just taking the reciprocal of both the y and x direction. So this is typically just known as the Lineweaver-Burke. And so our y-axis here now is 1 over our velocity, and our x is 1 over the substrate concentration. And for this, we would typically see a graph like this, where at this point right here, where our data has crossed over the y-intercept, this is our 1 over Vmax, and in our x-intercept is basically our 1 over Km. And so because we have a slope here, we know that our y is 1 over Vmax and our x is 1 over Km. Evidently, it's Km over Vmax, since we had to take the reciprocals from both of them. I think a keynote to remember is if you have, let's say you have a Vmax that's greater than the original, the graph, instead of going up in the y direction, because we're taking 1 over Vmax, so 1 over a greater value, it's typically a smaller value then in the y direction here, because we're taking this reciprocal. So let's just say it's somewhere around here, closer to the origin, and vice versa for km, if it's like greater than the original, then we would have something towards here. And yeah, I think that's pretty much it.